afternoon, good evening, everyone. Welcome to the third round or the third session of our little mini series on agroecology and the transition to sustainable food systems. Today's topic is recycling. We have Chris Turbrück and Ben Wild with us to talk about one of the principles of agroecology being recycling and what role recycling plays also within agroecology. So maybe as an introduction, and for those who join us not for the first time, you know it already. So I tried to be brief and clear. After a short introduction of myself, we will hear two inputs. We start with an input by Ben Wild. After that, Chris Turbrück give his perspective on recycling and the role of recycling in agroecology. And then we will have a moderated Q&A session after the two presentations. If you have questions and you're hesitant to share them or address them directly, just use the chat function. If you have problems with your micro, just use the chat function in order to also be engaged in the discussion. And of course, if you have other ideas or thoughts in a way, you're always welcome to share that through the chat function. After that Q&A, we will close the public part, and then the students who are enrolled in the agroecology class, of which this public series is a part of, they will have also a chance to then directly interact with Chris and Ben afterwards. Just the role of agroecology and sustainable food systems. You all know global society is on a race to meet the Sustainable Development Goals. That race is, depending on each of the goals, very different in terms of achievement and probability to achieve these goals. And another important aspect is that these different goals are very interconnected. So some do support each other in achieving, and others also do somehow hinder each other in achieving. So if you focus on producing more food, then of course on the resource side that puts then another pressure on. But the holistic understanding of the Sustainable Development Goals does very nicely connect also with the holistic understanding of agroecology and also the different definitions we know about agroecology. Of course, agroecology has three kind of definitions. It's a science, it's a set of practice, and it's also a social movement. And that's why also it serves as or can support also the discussions around what do we need to address when we address sustainability issues within food system. It's about environmental aspects, it's very much about economic aspects, but also about social aspects within food systems. And these 13 principles, as suggested by the high-level panel of experts of the C Committee of World Food Security, they do reflect this holistic understanding of agroecology, but also do show that agroecology addresses different dimensions. The agroecosystem, with some of the principles highlighted here in green, where also recycling is part of it, but also other principles which do address more food system aspects. We talked about connectivity in the first of these lectures 2 weeks ago, and we will talk also about fairness in one of the next sessions. But it's not only that we distinguish between agroecosystems and food systems, it's also that there are different levels to what extent also what kind of actors are involved. Is it more interactions on farm level? We talk about level 1 and level 2 approaches, more incremental steps. That's where recycling is also placed. Then the question is, okay, do these principles address more than beyond farm boundaries, landscape and water catchments, or including also community within food system, or even overarching the entire society. So this kind of order helps us also to understand a bit the role of these different principles and what is the level where the principle addresses then also some of the key challenges our food system face. And with this series, as I said, we will talk about fairness next time, soil health. We just took different examples of work, of experts, of scientists, but also people working in industry or civil society organizations. They share their perspective, and that's for us very key also to have different perspectives, different viewpoints here around our virtual discussion table. Having said that, it's a great pleasure to have Ben Wild and Chris Turbrück with us today. We start with Ben Wild. He's postdoctoral researcher at the Sustainable Agroecosystems Group here at ETH Zurich. He will present around 20 minutes and then hand over directly to Chris, who is a member of the directorate of EAVAC and also group leader in solid waste management. So without any further ado, Ben, I ask you to share your screen and join the floor. Thanks, Ben, for being with us tonight.
Sure thing. Give me just one moment here.
Sure.
Can everybody see that in presentation mode?
You have to switch.
Switch again.
Yes, again, we tested it, and that's why tests are helpful.
It was is at the top.
Display settings.
Yeah. Where did it go?
It's just right of where you were before.
Yeah, I know it's not.
Oh, it's not showing for you?
No, it's disappeared, of course.
Oh, a bit more right, a bit up, right. We see it was cursor, but yeah.
One moment.
Just to we have thanks, Emil, for your underlying and making it very clear that agroecology and the 13 principles indeed address the entire food systems from environment all the way down after consumption also to health aspects. So thank you very much. And now, Ben,
It's good, Ben.
you're ready to go. Thank you.
Is that there?
Yes, perfect.
Okay. Sorry about that. Okay, so first I'd like to say thank you to the World Food System Center for the opportunity to speak here today. My name is Ben Wild. I'm a researcher in the Sustainable Agroecosystems Group at ETH Zurich, and my work is primarily focused on trying to find ways to capture, process, and recycle waste streams to enhance the sustainability and resilience of our food systems. So I thought that it would be important to first introduce agroecology as a concept. And so here I lean quite heavily on Gleesman, who defines agroecology as a way of redesigning the food system from farm to table with the goal of achieving ecological, economic, and social sustainability. I also find Mendez's articulation of predominant agroecology is very, very useful. And here there's a clear distinction between the first type of agroecology, which he argues is primarily focused on the biophysical components of food production, with an agroecology that also seeks to integrate transdisciplinary, participatory, and action-oriented approaches, and that is quite explicit and critically engaged with the fact that our food systems are political and economic issues. They're socially constructed. And then finally, we have Wetzel, who, as was indicated, sort of defines three facets of agroecology. So the first is that there is a scientific research approach. The second is that there has to be a set of principles and practices that can enhance the resilience and sustainability of food and food production. And then the third also includes a socio-political movement to affect what is hopefully equitable change. And then again, this leads to this idea of transforming food systems through agroecology. And here I think it's important to really think about the level, the scale of transformation that we're talking about, going from incremental towards transformational. And I assume everybody here is interested in agroecology. And so I think it's important for us to reflect as individuals where we would position ourselves on this scale. And so then with that, I'll move into the focus of this discussion, which is the recycling components of agroecology and recycling as a principle of agroecology, which is what I've been asked and invited to speak here today about. So what do we mean when we say recycling as a principle of agroecology? And so what I would say is that it's essentially a recognition of how natural systems function and an understanding that we need to try to replicate that more. And so waste is really sort of a human concept. Natural systems don't really produce waste. Rather, there's a cyclical flow of resources, of nutrients, of elements through nature. And so organisms utilize resources. They're pulling resources, elements from the air, from water, from soil. And they're incorporating these elements into their biomass as a means of development and growth. And when these organisms perish, then there is a process of microbial decomposition, and then the process begins again. I think it's important to recognize that recycling as a principle of agroecology is very old. It's not a new concept. What I've often heard is that this is a novel concept. You know, we like the term novelty in academia, but I think there's a bit of hubris behind this perspective. And I think it's important that we recognize that this is not new. So for example, Tenochtitlan, this is one of the largest urban centers in the world immediately prior to European colonization of the Americas. And that urban center across its entirety collected organic waste and used it to support sustainable food production through the Chinampa system. East Asian cultures are the same. So here's an example from an agricultural manual dated to 1697 in Japan. And the quote clearly indicates that there is an understanding of the importance of human excreta and the need for human excreta to be used to maintain soil fertility.
Ben, sorry,
Yes.
you're stuck on a slide for us. We see this slide. What is agroecology? It hasn't moved forward.
Not at all?
No.
What? Sorry about that, guys. Still nothing.
No, we are still on what is agroecology. Maybe you go quick out and come in again.
Yeah, give me one moment. I apologize.
No worries.
Are you there?
Yes, we are there. And we now see your slide transforming food systems with agroecology, the different levels.
So we're at facets. That was
We're
discussed.
at facets, yes.
Transformation of the food system.
Yeah.
I'm going to be speaking about recycling. We discussed, for me, what it means to be recycling in terms of agroecology, and some common perspectives on what that looks like. We discussed Tenochtitlan, which is one of the largest urban centers in the world that was regularly using recycling to support sustainable food production. We have the agricultural manual dated to 1697, where there is a clear indication of the importance of human excreta in terms of maintaining soil fertility. And now we get to Europe. And so here in the 19th century, there were very interesting discussions between Justus von Liebig, Karl Marx, and Friedrich Engels, where they were discussing this idea of spoliation and comparing agricultural systems that risked what they termed spoliation of the soil with systems that adhere to principles of what they called restitution. And these, I think, quotes give a very clear understanding that there was a very deep awareness of this need to incorporate recycling, even recycling of human excreta, into agricultural production. So recycled inputs can provide necessary plant nutrients, so nitrogen, phosphorus, potassium, but where they're very, very critical is also in terms of their ability to provide organic carbon back to soils. So organic carbon is absolutely necessary, and the incorporation and maintenance of organic carbon has a lot of very clear benefits for soil, chemical, biological, and physical properties. There are also other management practices that are often suggested by agroecological principles that can also maintain or increase soil organic carbon pools. So conservation tillage, crop residue management is very important. The cover crop incorporation is often suggested or recommended. Different crops have different abilities to maintain soil organic carbon pools, and also the introduction of organic inputs. So manure, compost, recycled inputs that can also provide other necessary inputs, for example, for animal feed. And so what I would argue is that one of the key limitations facing our transition towards a more sustainable food system is that there's often an undue focus on livestock manure as a key and really only input possible for organic agriculture. And we can see here for manuals from the FAO, from FEEBLE, the Research Institute of Organic Agriculture, where they put livestock front and center. And I'm not suggesting that we should eliminate livestock from our agricultural systems, from our food production systems. In many cases, livestock are critical, but they're far from the only potential source of inputs. So when we're talking about inputs, alternative inputs, we can be talking about food waste, we can be talking about green waste, we can be talking about timber production waste or other process wastes that are produced often in enormous quantities. So here we can see municipal data coming from Msunduzi, which is a municipality in KwaZulu-Natal, South Africa, which is an area where I've worked for a number of years now. And these municipal data suggest that the total biodegradable waste produced within the region is somewhere in the order of 55,000 tons of biodegradable waste per year, of which very little is actually recycled. So what we're talking about is across every city in really the world, enormous quantities of biodegradable waste that when processed could provide very, very valuable inputs, not only for plant nutrients, but also as a source of a sustainable source of organic carbon. Human excreta is also often overlooked. Again, we all produce human excreta. There are 7 billion of us on the planet. This is in urban environments really a very serious sustainability challenge, how to deal with this, how to manage this sustainably and equitably. And urine and feces both, the literature is quite clear, when they're introduced into agricultural systems, can increase yields. So what am I trying to say here? So the point that I'm trying to make is we need to start to really rethink how we view the city. We need to start looking at the city as a reservoir of agricultural nutrients that can sustainably support food production. And so moving from a rural to an urban context, there is this relationship that becomes very important, and at the moment is really not being taken advantage of, the potential of this relationship. And so if we start thinking about how to restructure this relationship, we really need to start thinking about creating a loop. So what we need to start doing is thinking about the rural areas as places of food production, where food is being transported to urban areas where consumption is occurring, and then creating the processes necessary to capture that waste, to process that waste, and to return it back to the farms where it started. And so this is, I think, really, really important, is cities become fundamental, in my opinion, to our ability to sustainably grow food moving forward. And this is what we're trying to do with the RunRes project. So the Rural Urban Nexus, establishing a nutrient loop to improve city region food system resilience. This is an 8-year project funded by Swiss Development Cooperation. We're operating in Ethiopia, Rwanda, DRC, and South Africa. And we're trying to do exactly that. We're trying to close loops. And I will give one concrete example in Ethiopia. Here we have innovations that are being supported by the local university, by the municipality, and by a number of entrepreneurs. So we've done our best to restructure the solid waste management system. We've replaced donkeys with dump trucks. We have in educational campaigns to introduce the idea of waste segregation, which I would argue is fundamental to this concept. We're working with the waste collectors so that they can support at the household level successful waste segregation. All of this segregated organic waste is being taken to our composting facility, where we now have industrial scale composting occurring with the introduction of this new equipment. We're producing high quality compost at scale in the urban environment in Arbaminch. This compost is now being sold to banana farmers across the region. And that, again, that organic carbon is allowing them to maintain their production sustainably. And we also have value addition. So we have that banana that's being grown sustainably and is being taken now to a new processing facility run by some of our collaborators, where they're producing banana flour and baby formula. And so this idea of synergy becomes very important. And what I would argue is that this is an example where we're developing synergy through the urban environment into the rural and back. We're cycling nutrients, we're cycling food, and we're cycling capital within the local community, which is a key tenet of community-based economic development. Very quickly, intersectoral dialogue becomes crucial here. So in Bukavu, in the DRC, we conducted a social network analysis of waste collectors and agricultural, of waste personnel and agricultural personnel in the region. And what we found was that there is no dialogue. There's no connection between the solid waste management experts, the sanitation experts that are struggling with too many nutrients in their urban environment, and the agricultural experts that are struggling with the exact opposite problem. They're desperately looking for the nutrients that they need, for the carbon that they need to maintain their production. And this lack of discussion is, I would argue, a key challenge facing the scalability of this model. But through processes that incorporate principles of transdisciplinarity, what we can see is the potential to link these actors together, to bring them together to the same table so that they understand one another's problems and can find solutions that work for everybody. I have enough time for just a quick discussion on challenges, and in a word, I would say economics. So here, this is from a manuscript that I've been working on. I have this concept of commensurate pricing, which is the ability of a farmer to purchase fertilizer at a given price point. And what my data show is that chemical fertilizer is just far more cost effective than any of the locally produced fertilizers derived from recycled products that we can produce on site. These data are coming from Ms. Nduzi. And this is another key impediment, is that industrially produced fertilizers are very, very cheap. And that when you're a farmer with a limited amount of financial capital and you don't have time and money to engage in a long-term effort to switch over to an organic system, it becomes very difficult to avoid the most cost-effective and short-term solution. I would say that this is a fundamental challenge facing the scalability of this circular and alternative model of food production. So I've discussed recycling as the focus of this presentation. I was also asked to sort of link this with other concepts or principles of agroecology, and I reflected on this a bit. And I think that I can make a strong argument to say that essentially for these FAO principles, these 10 principles espoused by the FAO, they're all very much linked with this concept of recycling. The only one that I thought was a bit of a stretch would be culture and food traditions. So with that, I'd like to thank the audience. Let me apologize for the technical challenges in the beginning. And I'm sure we're all looking forward to the next presentation and to the question and answer. Thank you very much.
Thank you very much, Chris. I ask you to share your screen.
Okay, so we'll take questions later.
Yes.
Okay, perfect. Okay, hopefully that works.
So far, it looks good.
Excellent. Let's hope I don't face any technical problems. So good evening, everybody. Again, also thanks from my side for being invited to talk. My name is Chris Turberg. I'm with EAWAG, that's the Swiss Water Research Institute of the ETH domain. And my field of work is actually solid waste management, as Martin already briefly introduced me. So actually, I'm not an agriculturalist. I don't come from the agricultural side. I more come from engineering and from, I would say, city engineering, and links very nicely to what Ben was just explaining. So I actually come from the city problems and trying to solve those city problems, and so coming from the other side. And of course, circular economy is a big issue in waste management, not only on the organic side, but also on the inorganic side. This is a diagram, what they call this the butterfly diagram from the Ellen MacArthur Foundation, which is very much engaged on all aspects of circular economy. And so what we typically face or are tackling is really, let me get my laser pointer here, is really avoiding, one big issue is the objective of avoiding these negative externalities. And avoiding these negative externalities can actually be done by really connecting and closing these cycles. And as you know, that is also one aspect. The concept of agroecology is closing the loops, closing these cycles. So if we focus on the organic part and not on the inorganic part, often, you know, I start actually come from consumer, and I start thinking about, okay, what are the impacts of bad waste management or insufficient waste management on society, on the environment, on landscapes. And of course, the organic fraction has a significant impact on that. Mismanaged, you know, it lies around in settlements. It attracts animals, rodents that transmit disease. It's also a source of greenhouse gas emissions. So by anaerobically degrading in landfills or dumps, it emits methane, also N2O. This is very potent, much more potent than carbon dioxide, so has a significant impact on greenhouse gas emissions. And then finally, also in terms of pollution, so it's nutrients. So nutrients at the wrong place also create pollution, or groundwater pollution, river pollution, as you can see in these pictures. So that's, in a way, my starting point is to think about, okay, what are the best mechanisms to actually reduce these impacts. And if we look at organic waste, which creates all these problems, as Ben was already showing, there's a wide range of organic wastes seen from a waste management perspective. You know, when we talk about agroecology, we often talk about this, I would say, the agricultural sector, livestock sector, as was mentioned. But also, as Ben already mentioned, you know, there's the whole city environment. There's the feces, the waste that humans produce. There's even the commercial environment, and and that also produces organic waste. So I think what is important is also, you know, to look a bit broader than only the farm. And I think that's something, when I was looking at the concepts of agroecology, which disturbed me a bit, is that the recycling element is often considered or looked at from at the farm perspective. And I think that is not sufficient, because the flows of nutrients leave the farm and accumulate in cities, in settlements. So one needs to take more, I would say, a system perspective. And if you think about waste management, what we have here is the concept of the waste hierarchy, where the highest priority is to avoid, and then if it cannot be avoided, to reuse and recycle. And this, of course, fits very nicely also to the elements of agroecology. And this realization actually even led to this aspect of a specific SDG. As you might know, if you know the SDGs, SDG 12, ensuring sustainable consumption and production patterns, with a specific target 12.3 on halving capital food waste at retail and consumer, and reducing food losses along production and supply chains. So this again, of course, connects very nicely to the aspects of agroecology. And I think it's interesting, if you look at the different geographical context, to look at where these food wastes and food losses actually occur. So you see here food losses, what we define as production, losses from production, from handling and storage and processing, and then connected to food waste, which is more at the distribution and at the consumption level. And what you see here in these bars are the different geographic locations. And you see here there's quite a different pattern where you start to have to thinking about differentiation in terms of where these wastes are generated and how you would bring them back into the system. You see here more the industrialized countries where the most of the organic waste actually is derived or comes from the consumption and the market system, whereas in the low income settings, South Asia, Southeast Asia, Sub-Saharan Africa, it's mostly at the production, handling and storage and processing where many of these wastes are generated. So that puts also into perspective where we think of recycling and treatment aspects. So as you know, agroecology favors the use of natural processes, promotes closed cycles, and what I observed is that often this concept of, if you think about the diagram, the butterfly diagram I showed you before, this closing the loops is often understood or implicitly understood as closing the loops inside the farm, and not actually considering the whole cycle through production, consumption, which actually happens at another point and not on the farm. And I think only if we start including that, that's where we really get the big masses and the big amounts of nutrients and wastes, as Ben was also saying, including even excreta, urine, and recycling those aspects. So if we quickly just go into some aspects of the treatment of the recycling process, I think what is important, I like to distinguish these elements here, is first of all the source. Source also determines how it can be treated. That defines or gives you possibilities of the treatment technology. A treatment technology results in certain products which have a certain end use. And so the portfolio of options is actually quite big, so it's not that we don't know what to do. It's more connecting all these things together and bringing into the context where it's most economically feasible or logistically feasible. That's the biggest challenge. And one aspect that was already mentioned by Ben as well is the aspect of segregating. So making sure that increasing the purity of these waste sources, so to allow it to be recycled, that is one of the essential aspects to make sure that also economic feasibility and quality is ensured. And so the aspects that needs a lot of participation from the waste generators, it also needs behavior change. And in my experience, one of the biggest challenges in the whole recycling of organic waste actually comes from, of course, trying to connect these loops, but these loops between city and rural areas cannot be connected because the waste as it's as it's generated is typically mixed. And as soon as you have a mixed waste, your quality of your waste decreases significantly. It's much more economically, much more difficult in terms of sorting. It needs more infrastructure, equipment, labor, higher increase of cost, and lower end product quality. So I think this is really one of the biggest challenges in really making this recycling happen. Just quickly going through, if we still have some time, some technologies. You're probably familiar with most of these technologies. I'll just give it just a brief, a short overview, and I would like to then focus on black soldier fly waste processing, mostly because that's something we're heavily engaged on with research. Composting, as you know, the most simple process, a very old process, a very well-known process, which creates, in a way, a value, which is actually the compost itself. Unfortunately, that typically does not have much economic value, and therefore taking waste from cities producing compost doesn't make economically is very difficult to argue for. That's why in Switzerland, compost is actually given often free of charge from municipal systems because the attractiveness and a price is very difficult to set. Then anaerobic digestion is kind of a step more complicated. It also has a compost, which we call the digestate. So in addition to the compost, it creates the value product of the gas. So gas as a fuel, and also can be done in small scale. So it could be done on farm scale, actually often used in combination with manure, very well established in China, in South Asia, in India, Nepal. Of course, a bit more challenging in terms of operation and maintenance. Then carbonization, where you carbonize or pyrolyze the waste and create char. This has become very attractive now in the last years, thinking about biochar as also a carbon storage to capture carbon and there contribute to greenhouse or climate change. These can also be done in large-scale systems, but even in small-scale systems, as you can see here, the picture. This picture here is a system that we developed in Tanzania through research to create char from agricultural waste which arrive at the city and are then not used further. And finally, some other ones before I come into black soldier fly. There's, of course, also direct livestock feeding. Not allowed in Switzerland anymore to feed organic waste to animals directly. But there's also briquetting, so densification and using as fuel or direct application on fields. And the last technology that I would like to share with you is the one that we're researching quite a lot on, is using an insect, the black soldier fly, as an ideal waste management. So here we use the life cycle of the fly, and in its larval stage, the larvae consume a lot of waste. So from 1 ton of waste, we can actually harvest 250 kilograms of fresh larvae within 14 days. These larvae are very rich in protein and fat. That product can substitute fish meal and other animal feed, especially for livestock rearing. And in addition, we also have a residue which remains, which is similar to a very good compost, can be used as fertilizer and soil amendment. So besides having a compost, we also have a high value product as animal feed. When we look at the cycle, we typically keep part of the harvest to pupate and then to close the cycle through flies, which then mate again and lay eggs. So if we look at this facility, we have, in a way, we close the cycle, as I just said, through a nursery. Then we have a waste pre-processing. So we prepare the waste and we connect the waste to the larvae. So we feed waste to the larvae, and thereafter we harvest and post-process the larvae to different products for the market. You can see here some examples. This is from a facility in Indonesia, medium scale facility in a nursery where we rear these flies so that we can have eggs and larvae that hatch from the eggs to use for waste treatment in these boxes, in these crates. An example also from Kenya here, and the example from Indonesia. What is interesting now for an agroecological aspect is that we can even do this together with farmers. So this is what we call the outgrower insect farmer model. So where we have maybe a central unit that ensures certain complex processes, and an outgrower insect farmer can then feed the waste to the larvae and harvest the larvae, either using the larvae directly on the farm for livestock feed or supplying it back to a central facility for post-processing and marketing in a larger market. So we can actually expand that and have, in a way, a decentralized network of central unit with outgrowers treating waste. And that is also possible on small scale. It's a project that we're going to just start now in Uganda and Malawi, where we work together with farmers and to co-develop systems where they on a part-time basis as a supplemental activity can actually rear larvae or grow larvae using waste, either from the farm or delivered to the farm. We have a lot of information on black soldier fly waste processing. You can check our web page. There are guidelines how to do it. There are videos teaching how to do it. There are cost models to calculate if it makes economic sense. So feel free to browse on our web page to check to see more. So my take-home messages. So the waste is abundant. That's not the problem. There's lots of it around. We need to connect the waste with the treatment facility and bring it back to the places where the products are used. And that was really what Ben was saying. And that sourcing is not so easy. Making sure that it's separate, that it's of high quality is tricky. A variety of treatment technologies exist. And the challenge is really to think about which treatment to use, which of course depends on biowaste and the local context and the expected objectives. So I think that's what I wanted to share with you. And thanks very much for listening.
Thank you very much, Chris and Ben, for both of your inputs. Thank you very much. I see some applause. It's silent, but it comes from heart, I'm sure. So are there any questions to either Ben or Chris at this point? Who wants to break the ice?
Hi, is there any tool to say, yes, I want to ask a question?
No, there is a normal, if you go
the reaction. Yes, now I see. Yep.
But now you're with us, so Kaiser, please.
Hi, thank you so much for the great presentations, both of you. But I have a first question to Ben, because you mentioned that the comparison between the standard chemical fertilizers in comparison to the organic ones is unfortunately better. So it's cheaper to buy chemicals or the ready fertilizers than to produce or recycle the organic waste and upcycle it. Why I'm asking? Because I'm a startupper and we patented a technology to extract NPK out of organic and biomass. And we are also able to extract and produce in standardized process humic and fulvic acid. And we prove with our technology the opposite. Of course, you have the initial cost of the technology to buy or lease, or we are trying also to figure out the process or the model as like fertilizer as a service. So we are going like really, we are cutting out all the costs. Within one production season or cultivation season, the particular farmer can have already the full return on invest by using it. So,
Yep.
you know, to make completely exactly to break the stage that the farmer is, need to buy, or it's depending on the supplies from the producers, rather to be completely independent and self-sufficient.
Yep. No, I mean, so the context becomes very important, right? And so, and also the fertilizer that we're talking about becomes very important. So it does sound like what, I mean, the process that you're talking about, I mean, if it's cost competitive when you're extracting these nutrients from organic sources, then that's, I think, you know, very promising. In the context in which I'm working in these city regions in sub-Saharan Africa, it's been a big challenge, especially when we're talking about compost. So if you look at the price points of you know, stored urine, if we talk about alkaline dehydration for urine, there we can become quickly much more competitive with the standard inputs that are being used.
Okay.
But again, when we have to find a way to get organic carbon back to those soils, and that's very difficult. I mean, you're talking about a very bulky product with very low quantities of NPK, and that's really what farmers, when they need a short-term return, that's what they're looking for. And making the argument that longer-term decision making and investment in long-term soil health and fertility is necessary, that becomes a bit of a challenge.
Yeah, because we are also looking at the supply chain shortages in the fertilizers, because the production is mainly made in the northern part of the globe. And like just the case of Brazil, that Brazil is importing 95% of NPK out of one country, what I don't want to mention the name now, but I think you know who I'm, because it's, there are just like a few, 11 countries who are really doing it on a big scale. So
Certainly.
Yeah, so this is
Just to add to that, I mean, I was just in Guatemala, and farmers there were telling me that they're seeing a threefold increase in the cost of fertilizers over the past year, and that they're going out of business because of it. So I mean, industrial fertilizer production, you know, it is susceptible to these price shocks, and that does create some opportunities, I would say, for looking at alternatives.
Okay, perfect. Thank you so much. So now I understand more the context why it's organic.
Sure.
Unfortunately, in this context is more expensive, but maybe we should stay in contact, and I will show you what we are doing.
I'd love to learn more.
Thank you so much.
Thanks, Kasia. Nina, you have a question.
Yes, thanks to both, to Ben and Christian. Christian, I have a question. In earlier times, when we looked at the LCAs for the insects, be it for bioenergy or feed or food, the energy costs to keep those insects warm and cozy so that they actually grow nicely was very decisive. Now, your example was from a rather warm area, looked tropical. So is that a limitation to spread that out, or could one also use, let's say, renewables, or is that then still too expensive in order to make a profit out of that black business? And the second question then, depending on what the price is, would you see the growth potential then rather for some, let's say, staple food, or rather expensive stuff that people then can sell to a high price?
Yeah, that's correct. I mean, if you think about this technology in the context of colder countries, I would say Europe as a good example. You know, there are factories already processing. There's a big, large factory that will start to go in operation in France. There's one in the Netherlands. I do feel that the issue of climate and of course climate control, if it's too cold, so heating in a closed container, I feel is a big barrier towards economic sustainability. And if you look at those plants that are operating in Europe, they're actually not producing animal feed for livestock rearing. They're producing animal feed for pets. So it's mostly cat food, dog food, and some bird food. And the reason for that is, first of all, there's a region of legislation, because there's no legislation regulating what you can put into the food for your pets. There's much more strict regulation of what you can use as a source to make insects for livestock, because of course that's the food system. So there it's quite strictly regulated. And of course, the second reason is the margin of profit is much, much higher. We spend enormous amounts on pet food for our dogs and cats, and we pay lots of money for that, which a farmer would never pay for feeding their livestock. And I think that is the reason. But I really do see the potential very strongly in tropical countries. And especially when I was trying to make this link, to this outgrower model where the farmers can actually produce some of their animal feed on farm, in a way, in their opportunity cost as a side activity. Of course, that also has a cost, but it's not an economic, it's not a cash cost. It's a labor cost. And that's what we're trying to explore now in the African context, to see how that can connect. So you really create this resilience at the farm level, where you become a bit independent from also this fluctuating animal feed in a way. So I think that's where the big potential is.
Yeah, thank you.
Thank you. Chris, may I just a follow-up? Is that what you just referred to, the difference between livestock and pets? Is that also true for aquaculture? Because often you hear that insects have a huge potential in aquaculture also to reduce the input.
Livestock including aquaculture.
That includes aquaculture.
Yeah. I think there's extremely high potential for aquaculture. And I think also especially now, for instance, in I would say the low income setting, where often aquaculture is done even as a side activity on farm. So it's not in an industrial scale, but it's maybe a pond that you have, or even some constructed units where you have tilapia or something like that, which of course can feed very nicely on larvae.
So industrial scale, again, too high cost, but then if you have different costs or opportunity costs in a way, then that could be valuable.
If industrial scale increases costs, and industrial scale, and at the moment, again, it's in a way like Ben was saying for NPK, if you compare the price of producing larvae animal feed and compare that to the prices of soy animal feed or fish meal animal feed, then it becomes quite difficult to compete, because it's extremely cheap, because all the externalities are not included in those prices.
That's what I wanted to say. It's just still also a question of the policy framework, which does then, to a certain degree, also lead to certain non-covering of externalities, right? Other questions to Ben and Chris? It's now your chance, of course. There is also possibility to I see that there are, yes, there is a chat message in the chat. I will quickly translate it. Question for Chris. So it's from Barbara. If she remembers correctly, EU targets to recycle 65% of municipal waste by 2035, which includes bio-waste. Do you think this is feasible?
Yeah, it is feasible.
Realistic.
It depends on under what conditions. I think the challenge is, of course, getting it. as I was saying, is source separating it so that it's available to recycle. And then it's the question, are you thinking about cost recovery, or does it have to be, I would say, income generating or profit generating? And there I think, no, it isn't. That's not feasible. I mean, waste management is not income generating. If you throw waste into the incinerator or you throw into a disposal site, that doesn't create any income. I mean, it creates some income maybe through, heat production in an incineration plant or so, but it's not cost recovery. Forget that. So I think, it comes at a cost, and then it comes at the challenge, I feel, is getting the waste. If you really want it as a good source to really enter the recycling chain, it needs to be separated. It needs to be segregated at source. That's the only way you can really get things. And that means, changing the whole system also of waste management. I mean, here in Switzerland, it's already introduced, the green bins, things like that. But I think there, participation is not always very high, and it's more, voluntary sometimes even. So I think those aspects need to change so that that can be achieved.
Thank you for this assessment. Nina.
I think you're addressing a very important point, which is the separation and the quality. We were once told by a organic livestock manager here in Switzerland who used a city compost in his barn that he will never ever do that again because there was so much plastic in there, and that he feared that his livestock would actually eat this plastic and get ill. So that's, I think, also a large, problem if we don't get that rather clean. So yeah, just as a comment, no question, no no good solution.
Just to build on that, we in Runres, we've spent 4 years now trying to find ways to separate waste at the household level. And I would say that we've been able to do that with varying degrees of success. So in certain contexts, we have been able to do that successfully. And sometimes that's been done organically. So for example, we have a co-composting facility in South Africa. And the organization that's running that facility, they do they have personnel that when the green waste that they're actually getting paid to receive comes in, if it doesn't meet their standards, then the person that tried to bring that in is essentially not allowed to bring any of that material back again.
Mm-hmm.
And we've also tried to initiate education campaigns through the municipalities where we're working to do the same. And as I said, this is not an easy thing to do. These behavioral change issues, they take time and they take resources, and if we can't find a way of segregating that waste, then as Chris said, is your product quality, and as Nina said, is your product quality goes down, and to the point where I would argue that it's really not worth it. It's a fundamental step, is that segregation, in my opinion.
If I just may add on something here, in the low income context where typically I'm working, even the high, well separated wastes don't get recycled. I think there is really an opportunity still to capture the low hanging fruit, the easy accessible stuff, right? That's wastes from food processing industry, which are already in a way pure, which are not contaminated, or market wastes, which are typically, I would say, 95, 98% pure. So even those easy locations where brewery waste, slaughterhouse waste, those things, could be easily captured. But I think there, even the opportunity is not taken. And I think, of course, let's not start with the most difficult subject, trying to get people, household waste to be separated. But even starting with those easy wastes could already, move us a lot further in this recycling endeavor. So
But is that due to awareness or culture or simply not knowing about the potential? I mean, you said that people didn't know about each other, so that was one example. Would you dare to give like an overview, or would you say it's very context specific? It could be everything out of those three plus more reasons?
In my experience, it has to do with economics. You know, so everybody knows how to do composting, but composting as a business doesn't, you know, economically doesn't, nobody's interested in doing only composting. And as soon as our experience from Indonesia with black soldier flies is when entrepreneurs see that there is an economic value because the value is much higher in terms of sales, then, and knowing how that technology works, showing that there is an economic potential, maybe, you know, demonstration or maybe experience from other sites, you know, that triggers a lot of interest. I mean, we were working in Indonesia, our project, we started off with one pilot, and towards mid-project, we had 15 partners that wanted to, you know, set up plants. We recently just made an evaluation. It's now 2 years since the project ended, and 12 of the 15 are still operating. So it seems, you know, that's a pretty good result, and without any doing of us. So after that end of the project. So I think that shows that there is, you know, there is economic potential in it.
The other thing I would add is that there is a common good component to this, and I think, I mean, in my opinion, getting compost or organic matter back to soils is something that we have to find a way to do. And so there we have to find ways to structure partnerships, public-private partnerships, where we find ways to subsidize the cost of compost production. And I think we're seeing indications of that. You know, there are policy shifts now at the national levels, for example, in Ethiopia, where compost is being produced, farmers are being encouraged to do it, demand is growing. And I think that there are opportunities to make a very difficult process sustainable. Financially difficult process.
Financially difficult process. Yes, I understood that. Thank you very much, both of you. Last chance for a last question. If this is not the case, I really want to thank you both for sharing your perspective and making us aware that recycling should be seen in a larger context, much larger than the agriculture, the farm only. So thank you very much for being with us. And Ben and Chris, I ask you to stay quick for a students round. So the students enrolled in the course, stay on, and the others, we see each other next week for a discussion on fairness. And also next week, we are going to upload the recordings of the prior sessions. So thank you, Ben. Thank you, Chris. See you in a second.